Our report is about object-oriented approach to requirements. Part of this report are object-oriented requirement. The system activities, a use cases scenario view. Identifying input and output, the system sequence diagram.
I am Nikki, and today I'll discuss to you about the object-oriented approach to requirement. First, we give you a short info about object-oriented. Object-oriented system is the data is represented as a discrete object with which the user and other object may interact. Each object contains data as well as information about the executable file needed to interpret that data. Objectives of the requirements is understanding the user's need, business processes, and also the system to support business processes. Another objective is to understand and define requirements for a new system using object-oriented analysis model and techniques. Object-oriented requirements. Object-oriented modeling notation is Unified Modeling Language or UML. Unified Modeling Language was accepted by a Object Management Group or OMG, this as a standard modeling technique. The purpose of this Object Management Group is, the first one is to promote the theory and practices of the object-oriented technology for the development of the distributed system, and the other one is the common architectural framework for object-oriented. Object-oriented system requirements are specified as documented through the process of building models. And the modeling process starts with identification of use cases and the problem domain classes. These are the things in users' work environment. Business event trigger elementary business process or EBP. These are the tasks performed by one person in one place at one time for the new system must address, and also as a use case. Use case defined as a functional requirements. Object-oriented requirements model. First model is the class diagram. Class diagram is the system component translating the models into programming code. And next we have model called use cases diagram and use case description. Use case diagram is identify the actors and their use cases, basically their goals. However, the use case description includes details of the use cases and how the actor used the system. Next, we have the system sequence diagram or SSDS. Define the input and output of the sequence and interaction between user and the system for the use cases. Next, we have the state machine diagram. State machine diagram object and model and dynamic nature of the system is describe the state of each object. And lastly, we have the activity diagram. Activity diagram describes users and also the system activities for use cases. Is a sample of use cases. Next, I'll give you a requirements diagram with OMG model. So we can see we have this with the business event, use case diagram, use case description, and the system sequence diagram. In the business object, we have the problem domain class diagram and the state chart diagram and also the activity diagram. Another chart I will be showing to you is the requirements of model, traditionally version object oriented. So we have the traditional approach and the object oriented approach.
Today, I will discuss the system activities, a use case scenario view. Use case analysis used to identify and define all business process that system must support. A use case is a collection of possible sequence of interaction between the system under discussion and its external actor related to a particular goal. Next, the actor. Actor someone interact with use case. Actor play two role with two system in the business, which is role played by user and outside automation boundary. Actor has responsibility toward the system input and the actor have expectation from the system output. Next, techniques for identifying use cases. First, you must identify the user goal. The actor is a specific role played by a system user and represent a category of users that demonstrate similar behavior when using the system. Each user have a EBP or the elementary business process. The task performed by one user in one place and in response to a business event that adds measurable business value and leaves system and data in the consistent state. Next, CRUD, wherein CRUD analysis technique contain create, read and report, update, and delete. Use case diagram. It is a simplest representation of user interaction with the system that show the relationship between the user and the different use cases in which the user is involved. Next, UML diagram or Unified Modeling Language. A use case diagram can summarize the details of your system users, also known as actor, and their interaction with the system. Use case can have a multiple use case diagram by subsystem or by actor. Here are the example of simple use case with an actor. Actor has responsibility toward the system input and the actor have expectation from the system output. Communication link, which is the actor participate in use case. Actors may be connected to use case by association indicating that the actor and the use case communicate with one another using message. Each actor must be linked to a use case while some use cases may not be linked to actors. Use case with automation boundary and alternate actor notation, wherein expand use case diagram with other actor and use cases. Relationship line allows each actor to interact with each use case. Automation boundary line drawn around the entire set of use cases. Define interface between actor and computer system. Use case of RMO order entry subsystem. Relationship includes or uses relationship. Use case calling service of common subroutine. A common use case can be reused by multiple use cases. Here are the example of order entry subsystem with include use cases. CRUD analysis for identifying, confirming use cases. I have said earlier wherein CRUD contain create, read and report, update, and delete. The information engineering or IE technique is to identify event, table, or directly develop use case diagram. Every class diagram must have use cases to support the CRUD and object instances. Next, use case description. It is a processing step for a use case to provide details of pre- and post-condition sequence of activities and exception condition in use case. Actor, a person or thing that use the system. Actor have a contact with the system. Scenario or instance, a particular set of internal steps that represent a unique path of use case. Describe actor interact with computer systems step by step to carry out the business activity. There are three types of description: brief, intermediate, and fully developed description. Brief description, it is a summary statement conjoined to activity diagram. Intermediate description, it is an expand brief description with internal flow of activities. Fully developed description, expand intermediate description for richer view. It is a superset intermediate and brief description, consists of 11 compartments and contain user, actor, stakeholder, EBP, and condition identified. Use case description components. Use case description will contain use case name and scenario name. Use case have actor and stakeholders. Use case description has two conditions: precondition and postcondition. Precondition is a set of criteria that must be true prior to the initiation of the use case. Postcondition, it is a set of criteria that must be true upon completion of the use case. Next, the activity diagram. Activity diagram is used to document workflow of business process activity for each use case or in scenario. Activity diagram can support any level of use case description, a supplement to use case description. Any activity diagram help you to develop a system sequence diagram. Here are the examples. Activity diagram, telephone order scenario. Activity diagram, web scenario.
Identifying inputs and outputs, the system sequence diagram. System sequence diagram, also known as SSD, is a type of UML interaction diagram. It is used to describe the flow of information into and out of the automated system. Used to model input and output messaging requirements for a use case or scenario. Shows actor interacting with a system. Shows sequence of interactions as messages during the flow activities. System is shown as one object, a black box. SSD notation. Actor, represented by a stick figure, a person or role that interacts with the system by entering input data and receiving output data. Object, the box labeled as system is an object that represents the entire automated system, shows individual object and not class of all similar objects. A rectangle with the name of the object identified the colon is optional. Underneath the actor and the system are vertical dash line, called lifelines or object lifeline. A lifeline is simply the extension of that object throughout the duration of the SSD. The arrows between the lifelines represent the messages that are sent or received. A message is labeled to describe both messages, purpose, and any input data being sent command that has a syntax. Output message has shown as dash arrow, a slightly format and meaning. An optional note can be added to explain output messages. System sequence diagram SSD notation. For example here, the stick figure is the actor or user that interacting with the system. The user input a message like catalog ID, product ID, or size. Then the message is going to an object that represents the automated system. Underneath the system is the object lifeline, shows sequence of messages top to bottom. Then after the process, the item information like description, price, quantity is the output message that will go back to the user. SSD lifelines. Vertical line under object or actor shows passage of time. If vertical line dash, creation and destruction of thing is not important for a scenario. Long, narrow rectangles. Activation lifelines emphasize that object is active during part of scenario. SSD messages. Internal events identified by the flow of objects in a scenario. Request from one actor or object to another to do some action. Invoke a particular method. Asterisk indicates repeat or looping of the message. Brackets indicates true or false condition. Message name is the description of the requested service. It is omitted on the dash line return messages, which only show the return data parameter. Parameter list with parentheses on input messages and without parentheses on return messages shows what data are passed with the message. Return value on the same line as the message requires assignment operator, which is used to describe data being returned from the destination object to the source object in response to the message. Repeating message. For this example, the clerk input the messages add item, item ID, quantity. Then the input message using lifeline is going to the object, which represent the automated system. Then after the process, the output message, description, price, extended price will go back to the clerk. Underneath the clerk is the test condition for repeatedly. And all input and output messages will repeat everything in the rectangle. Developing a system sequence diagram. Begin with detailed description of the use case either full developed form or as with activity diagrams. One advantage of using activity diagrams is that it is easy to identify when an input or output occurs. Input and output occurs whenever an arrow in an activity. Diagram goes from external actor to the computer system. There are 4-step process for turning activity diagram into SSD. First is identify the input messages. See use case flow of activities or activity diagram. Second, describe messages from external actor to system. Name it or what the system is asked to do. Third, identify, apply a special condition to input messages, iteration or loop frame or alt frame. Fourth, identify and add the output return messages. As explicit, return on separate dash line. Activity diagram and resulting SSD for telephone order. For this diagram, the customer calls the store and gets the order clerk. The order clerk verifies the customer information if new or maintain account. This input message will go to the automated system. Then system will create a new order. Going back, the customer requests an item to be added like catalog ID, product, and size. Then the clerk verified the enter item information. SSD of the web order scenario for the create new order use case. For this diagram, the customer input a message to request new order. The system will connect the customer to the home page and links the order page. Then the customer input appropriate information if maintain customer or new customer to establish a account. If existing customer will log on to begin order. Then the system starts a new order and display the catalog frame. The customer browses the catalog. When the customer finds the correct item, he or she requests it to be added to the order. The system will add it to the shopping cart. The message will repeat when the customer wants to browse the catalog and add item to the shopping cart. When the customer is satisfied, he or she requests to end order. Then the system displays the summary of the ordered items. The customer review order if she or she wants make any changes. If the customer is satisfied, he or she will accept the order. The system will display payment screen. The customer enter payment information. The system will display summary of information and sends confirmation email, and system will finalize the order.